Question 6a. We've got these matrices here, A, B, and C, and we need to write down the matrix products which are possible, but we don't need to evaluate these products. So for a matrix product to be possible, the inner dimensions must agree. So let's start by looking at, well, what are the dimensions of each of these matrices here. So A, 2 rows and 2 columns, so that's a 2 by 2 matrix. B, got 3 rows and 2 columns, so that is a 3 by 2 matrix. And C is just 1 row and 3 columns, so that is a 1 by 3 matrix. Okay, so the only ones that are going to be possible is B times A and C times B. So let's look at why that is. Well, if we do B times A, well, B is a 3 by 2 matrix, A is a 2 by 2, so those inner dimensions there agree. And C times B, well, C is 1 times 3, and B is a 3 by 2 matrix, so these inner dimensions agree. You can try all the other combinations, but for each of them, those inner dimensions will not agree. So for example, if we wanted to do A times C, so I'll write that over here, if we did A times C, well, A is a 2 by 2 matrix, C is a 1 by 3 matrix, and these inner dimensions here are not the same. Okay, so that will not work. And just one more example, if we wanted to do, say, A times B, we run into the same sort of problem. So A was 2 by 2, B is a 3 by 2, and these dimensions are not the same. So the 2 and the 3 are not the same, so we can't multiply the matrix A by B. Okay, so these ones will not work. Okay, so that is question 6a. So the only ones that are possible are B times A and C times B. So for question 6b, part 1, we're given this matrix here, X, and we need to find the inverse of X. So just out onto the right hand side here, I've written out in red the formula to find the inverse of a 2 by 2 matrix. So if we've got that matrix big A, and the elements are A, B, C, and D, then the inverse is 1 over the determinant, which is the AD minus BC, and then our matrix is, well, the D and the A swap places, and the B and C swap signs. Okay, so for our one here then, so our determinant, so I'll write the determinant of X, well, that is going to equal this 2 times 3 minus 2 times 5. So that is going to equal 2 times 3 minus, and then we've got this minus 2 times 5. So that's just equal to 6 minus 10, which is equal to 16. So therefore our inverse of X, matrix inverse of X, that is going to equal 1 over that determinant, so 1 over 16. And then the 2 and the 3 will swap places, so we'll get the 3 and the 2. That negative 2 is going to become 2, and that 5 will become a negative 5. Okay, so that's 6b, part 1. For part 2, we need to find the matrix Z such that X times Z is equal to Y. So we'll start by left multiplying by X inverse each side. So then we get X inverse times X times Z is equal to X inverse times Y. So when we get this X inverse times X, or when we find the inverse of a matrix, X, and then times it by X, we just end up with the identity matrix. And anything times the identity matrix is just itself. So that means on the left side, we're going to be left with just Z. So Z is equal to X inverse times Y. So that's going to be equal to, Well, we just found x inverse. That's 1 over 16. And then we've got 3, 2, minus 5, 2. And then y is 4, 1, 2, 0. And that's going to be equal to, or 1 over 16. And so the number in the 1 position, row 1, column 1, that's going to be 3 times 4 plus 2 times 2. So it'll be that one, 3 times 4 plus that 2 times 2. So that's going to equal, or 3 times 4 is 12, 2 times 2 is 4, so we're going to get 16. And then in row 1, column 2, we're going to get 3 times 1 plus 2 times 0, so that's just 3. And then row 2, column 1, we're going to get minus 5 times 4 plus 2 times 2, so it's minus 20 plus 4, which is minus 16. And then we're going to get minus 5 times 1 plus 2 times 0, which is just minus 5. So therefore z is equal to 1 over 16, 16, 3, minus 16, and minus 5. And that is question 6.